Hey, 8th grade, it's Mrs. Whitty. We're going to talk today about the distributive property. Now, this is one of those properties or one of those rules that we've talked about before. We've talked about all sorts of them. Let's review. We've had commutative property, which talks about order. We've had associative property. And now, today, we're going to talk about one called distributive property. So, distributive property, you see the word obviously in it of distribute. So what does it mean to distribute? It means to give things out, right? You're going to give something to people. Well, math is fair, and so when we use a distributive property, we have to make sure that everybody gets the same thing. So let's look here. Let's say that you had a newspaper route, and pardon my drawings. This is me trying to draw, and I know you could do much better, but let's look at these. Let's say that every day you had two things you had to deliver to these houses on the block. And for our purposes, every house on the block got the newspapers. They got one paper of ads and then one of the newspaper. So you delivered them to each one of those homes. So this one got these, and then you went to the next one, and you threw those newspapers to that house, and then you went to the last one on the block and distributed those newspapers to each house on that particular block. So when we look at this, we could look at it and say that technically this was like saying that we had two papers for one house here and one house here and one house here. So what's another way that we could write that? Now, we could just add what's in parentheses, which would give us 1 plus 1 plus 1, which is 3, times 2, which would be 6 papers, and that would be correct. 2 times 3 equals 6. Now, we distributed those two papers to each house each time. So 2 to the first house would be 2 papers. We leave the sign the same. We added 2 more. So we added 2 more papers to the next house. And then we did it again to the third house and added 2 more papers to that house. Now we can add all those up. 2 plus 2 plus 2 equals 6. The same thing we got when we added the problem in parentheses first. So when we move forward, we can use this concept. We're going to start with using numbers just to show you how this works. So again, here we're going to distribute this 2 among everything in parentheses because math is fair. So 2 times 3 would be everybody, 6. Leave the sign in the parentheses the same, plus 2 times 2, which would give me 4, and my total would be 10. Now, does that equal what it would be if I had done what was in parentheses first? 3 plus 2 is 5, times 2 is 10. Yes, it does. Let's try another one. 3 times 4 would be 12. And we distribute the 3 across the other part of the parentheses. 3 plus 3, or 3 times 3 would be 9. So therefore 12 plus 9 is 21. So just a different way of grouping, a different way of thinking about it. 4 plus 3 is 7, times 3 will give you 21. So therefore again we have the correct answer. Now, what if we don't know what one of those numbers is? What if we have to do it with a variable? Same process follows. Even though you don't know what that number is, you're still going to multiply it and be fair to it just like you were to the constant or a number. So let's do this one. Distribute 4 items to the 2. 4 times 2 would be 8. Leave the sign the same. And this is called expanding the expression. 4 times b. So what's 4 times b? Simply 4b. Now, we have no like terms. Nothing's the same. They don't play well together, so they have to stay just like they are. 8 plus 4b. Let's try this one. 3 times a, 3a plus, and 3 times 2 would be 6. And again, that's as simple as we can get. It's as simple as we can get for this particular expression. Same thing can happen as if we do have a subtraction in the front here. We can also distribute this. So 6 times 2 would be 12. And now we take that sign. This is a negative 1, really. So 6 times negative 1 would be a negative 6. 12 minus 6 would equal 6. And if we see 2 minus 1, if we had done that first, that's fine. 2 minus 1 is 1 times 6. It checks out both ways. Same thing here. 5 times 5 would be 25. 5 times a negative 2 is negative 10. 25 minus 10 would be 15. And again, we can do this with variables as well. 7 times a, 7a, and 7 minus 4 times a negative 4 would be minus 28. Okay, so how can you use this to help yourself do other problems? Well, let's say that you have 26 times 3. And you want to do that problem in your head. Well, couldn't you think of that 26 as 20 plus 6? And then we're multiplying that times 3. So therefore, we can think of this as 3 times 20, which is a little bit easier multiplication, which would give us 60, plus 3 times 6, which would be 18. And that adding those together would be 78. So the distributive property can really help you out with mental math problems as well. Okay, so to sum up our lesson in math terms, if I'm only going to use variables and to use the rule in math terms or language, a times b plus c equals a times b plus a times c. A times b plus c plus d, we distribute it with everything in parentheses. A times b plus a times c plus a times d. A times b minus c would equal a times b minus a times c, working with everything that is in those parentheses. All right, so something to think about. What happens if you would undo the distributive property? For example, what if another way we could write 2x, what's another way that you could write 2x plus 2 and use a factor of both those terms and parentheses in your answer? So tune in to the next lesson to see how that might work out and to see if you're correct. See you next time.